Hello everyone, this is Mr. Mon again. So this is another video, as I promised, to solve one of the gravimetric questions that's been uploaded in week 3. This question is picked from the additional questions that I've uploaded for extra practice. I randomly picked question number 3. I think this question is a bit unusual because there's two molecules involved, so it can get a little bit confusing than the usual methods, but I just want to show you the technique that we're going to use to solve the questions. It's exactly the same as the rest, with slight variation. Okay, so remember, the key is to understand the flow of information, and second, you should only be watching this method of solving after you have given it a try. Okay, assuming you've given it a try and you could not arrive at the correct answer, then you may want to watch this to get an idea of how am I solving it. Okay, let's get to the question so that we can keep this short. Okay, so right, first step is to identify key information. Now, key information is, in this solution we have sodium sulfide and sodium sulfate. So this is two different substances, and the understanding is it's an impurity, which means in this sample it's largely made up of sodium sulfide and it contains a certain small amount of sodium sulfate, and the total mass would be 6.35 grams. That was dissolved basically in distilled water. Okay, and then excess barium chloride. So as usual, as what I would always say, first we want to see the flow of information. So, well, this is the flow of information. We're going to basically put in the mass, which is 6.35 grams into this, and then they're going to dissolve it, add a bit of water, so there's no particular reaction here, it's just dissolving. And after that, they have added barium chloride. Now, barium chloride, this results in a precipitation. So why? Because we know that, okay, there's two reactions taking place here. You have sodium sulfide and you have sodium sulfate. Now, both is going to react with the barium chloride, BaCl2. Oops, I've got the 2 here. So both is going to react with barium chloride. It's a pretty similar reaction. Well, both is going to result in formation of sodium chloride. So it's a 2 here plus barium sulfide. In this case, same product here, 2NaCl, and that's going to form a barium sulfate. So if you remember salts from your previous years of chemistry, barium sulfate is an insoluble precipitate. So in this case, both of these are basically insoluble precipitates. So it's what we are going to study essentially in this gravimetric experiment. Now, okay, change the color back. Okay, all right. So back to this. Then what they did was, once this is done, they have added HCl into this mixture, and addition of HCl tells us that it kind of dissolves this and only leaves us with this, which then they say they have filtered, dried and weighed, and the mass happens to be 1.67 grams. So the 1.67 grams refers to the barium sulfate. Okay, now first question is, they say moles of barium sulfate. Okay, so that's what we're going to do. So moles of barium sulfate, 1.67 grams divided by the molar mass of barium sulfate, 233. I've totaled it already, 36, and that would give us 7.156 times 10 to the power of -3. Please remember it's key to maintain at least 3 significant figure. Oh, that's the answer for the A. So I'll write it down here as well. 7.156 times 10 to the power of -3 mole. Don't forget the unit. Okay. Now the second part is they wanted to know the mass of sodium sulfate, the original sample. So it's worth taking note. Sodium sulfate here, 1 barium sulfate comes from 1 sodium sulfate. Okay, and in other words, 1 sulfate here, there's only 1 sulfate here. So the mass of sodium sulfate, how do we get that? We get that by getting the number of mole of sodium sulfate multiplied with the molar mass of sodium sulfate. But then again, what is the number of moles sodium sulfate? So using the equation above, we know that 1 barium sulfate comes from 1 sodium sulfate. Okay, that's the key. So if you have 7 point, which is from your A, 7.156 times 10 to the power -3 mole, then the mole of sodium sulfate is the same, which is 7.156 times 10 to the -3 mole. So multiplied by the molar mass of sodium sulfate, which is 142.06, and that would give us mass of 1.02 grams. It's actually 1.017 grams. I've rounded off to 1.02 grams, and that would be the answer for this 1.02 grams. Okay, that's done. Now the tricky bit, they said sodium sulfide. Now what is sodium sulfide? Sodium sulfide is this, and the barium sulfide that we have dissolved. So don't panic here. That's why the flow of information is important. The sodium sulfide and sodium sulfate both came from the 6.35 gram, and based on the given information, they said the only impurity of this substance in this anhydrous sodium sulfide was this sodium sulfate, and we have just analyzed the mass of sodium sulfate. So the mass, I can do it here. So the mass of sodium sulfide, which is the Na2SO3, will be equivalent to the mass of overall, which is 6.35 grams, and we minus the sodium sulfide that we have just calculated. Okay, so that would give us, I've already calculated this, 5.33 grams. So that's the answer here, 5.33 grams. And the last bit here, the percentage by mass, we'll use both of the previous answers, which is 5.33 grams divided by 6.35. So percentage by mass is done by mass of the substance that we are calculating over the overall sample, because they say it's the original sample, and you multiply it by 100. So in this case, I will give you 84%. Okay, so that's the final answer. All right. Okay, thank you very much. Hope you're enjoying your holidays and getting along this additional question on gravimetric and volumetric. And also, please read ahead. You already have the textbook. You already know where we are heading to next. I've already given you an intro on the electronic configurations. So please do read up on that so you come in prepared. Thank you very much. Bye-bye.